In today's video, we're using the same network topology as we had in the previous video, but this time we're introducing CapsMan to manage our wireless network. Our main goal is to ensure that our wireless internet connection stays stable and reliable at all times, even when network changes or failovers occur. However, depending on how we design our network, there are some key considerations to keep in mind. We'll look at different ways to integrate CapsMan into our setup and discuss how each choice impacts our network. Scenario 1. Using a non-VRRP device as CapsMan. In this setup, CapsMan is hosted on a separate device that does not participate in VRRP, for example Switch 01. Here's what this means. When the CapsMan server is on a device that isn't part of the VRRP setup, the configuration is simpler. Caps only need to connect to a CapsMan server. Since CapsMan runs separately, it isn't directly affected by VRRP changes. This means that if one of the VRRP routers goes down, CapsMan continues managing the wireless access points without interruption. In Scenario 2, we configure both of our VRRP routers to also act as CapsMan servers. This allows for a more integrated setup, but it requires more coordination. Here's what to keep in mind. In this setup, the caps connect to the VRRP virtual IP address rather than the routers. This allows caps to automatically switch between CapsMan servers if one router fails. Since the caps use the virtual IP for their CapsMan connection, when the primary CapsMan server fails, the caps will reconnect to the backup router that takes over the virtual IP. This ensures continuity in wireless management. It's crucial that both CapsMan servers on the routers have identical settings, SSIDs, security profiles, channels. This prevents configuration mismatches that could cause issues during failovers. To set up CapsMan in Scenario 2, where both routers serve as CapsMan servers while using VRRP for redundancy, follow these steps. Begin by configuring the CapsMan in one router. Define a basic configuration profile that both routers will use. This configuration includes the SSID and basic settings for all managed APs. To make sure that the configurations, SSID, security, channels are identical on both routers, export the CapsMan configuration from router 1 and import it into the other to ensure consistency. Set up caps to use the VRRP virtual IPs for each VLAN. This means that the CAS will attempt to connect to whichever router is currently acting as the VRRP master, ensuring continuous management during a failover. Now that we have the two routers configured as CapsMan, let's simulate a failure by disabling the link on router 1 to see if router 2 takes over as the master. We can see that router 2 take over the responsibility of managing the CapsMan. In this setup, both routers share the responsibility for wireless management using CapsMan while also providing gateway redundancy through VRRP. The key advantage of this design is that if one router fails, the other can seamlessly take over the duties of both routing and CapsMan management, providing uninterrupted network access. With the CAPS configured to connect to the shared VRRP virtual IP, the transition between CapsMan servers is automatic. Just remember that maintaining consistent configurations between the two routers is crucial to avoid any issues during failover. Thank you for watching. If you liked what you saw, please give this video a thumbs up. Subscribe to the channel for more networking tutorials and hit the notification bell so you don't miss any updates. Feel free to leave any questions or suggestions in the comments below. I'd love to hear your feedback. See you in the next video.